Hello, Dr. Vivek. Am I audible? Hello.
Sir, good afternoon, sir. You are audible. You are loud and
Yeah.
clear, sir.
Yes. Yes. Good. Good afternoon. Good afternoon, everybody. Yeah.
With your permission, sir, we may start if you want, sir, please.
Yes. Yes. Please go ahead. I mean, why to delay? Yes.
So, I all participants again in the day two FDP scheme. So, as I announced in last session, this current session is going to be very interactive. And let me introduce the resource person we have right now. Uh, I just want to welcome Dr. Atul Gupta, sir. He's, if the person you are belong to the MP, he's a well-known figure in the central India. He has done his BTech in SGITS Indore in 1991. He's a well-reputed and old institute of MP and completed his master from IIT Roorkee, earlier known as a University of Roorkee in 1993. After that, he has done his PhD from IIT Kanpur in 2007. Currently, he is working as a professor in computer science and engineering department and also head of the department at IIIT Jabalpur. He works in the area of software engineering, machine learning, and natural language processing. He has guided many master and PhD students and published more than 50 research papers in various international journals and conferences of repute. He is also reviewer of many top-class journals in software engineering, IEEE Transaction in Software Engineering, Journal of System and Software, and Empirical Software Engineering. He is a recipient of Drona Award from IBM India for leading a team of students for software development competition, TGMC 2010. He has received Best Paper Award in APSCEC 2013. He is leading one project as a co-PI for Electronics and ICT Academy and also coordinator Design and Innovation Center at IIIT Jabalpur. He is the author cum principal coordinator of Python programming course jointly offered by several ICT academia across the country. I'm so fortunate to have connected with the sir in many years, you can say, and believe me, he used to visit. He's so busy around the central India, or you can consider all the whole India. People used to call him as a expert in NLP or especially in Python. So without wasting time, not much more, I would like to call Gupta sir to enlighten us, including me, our participants in this FDP. So welcome you again, and sir, please, the control is hand over to you, sir. Please.
Thank you, Dr. Vivek. So nice of you. I mean, for your kind words and good words. I mean, I'm not that busy person. I'm just like maybe at times you may got this impression I'm trying to be busy, but not busy. So thank you very much for your kind introduction. Yes, can you allow me to share so that I can start? I mean,
Yeah,
I
let
don't.
me make you, sir, presenter. 1 minute, sir. 1 minute. Yeah. Now
And I
it
can
will be
see.
enabled at your end, I think, sir.
Yes, I can.
Now you can.
Now, yeah, I can see there are 34 participants.
Yeah, so I requested to join them as early as possible. So this time I approved very limited participant. Normally in Atal workshop they have a 200 more than participants. So it's very
Yes, yes.
difficult to manage it. Very difficult to manage it, sir. So this time I purposefully only allowed around 50 to 60 participant only, sir.
Okay, okay, great. So thank you, Dr. Vivek. Let me start talking to our participants. Let me share my screen. I think is my screen visible?
Yeah, it is clear. It is visible, sir. Please.
Yes. And where is this? So I think my presentation is also visible, right?
Yeah, yeah, very much fine, very much fine.
Yeah, so thank you everybody for making this session and attending this. I hope that it should be a useful session for all of you. In this session, we are going to discuss about a very interesting problem called text classification, right? So, how text data can be used to solve problems, right? So, and what kind of problems we can solve using textual data. So, as you know, the text data is enormous and is going very with a very high speed and high rate, and on a daily basis, and you can see like lots of text data is getting generated, right, over internet, over social networking sites, news, emails, books, articles, all kind of articles, right, documentations, and many more. So maybe if you are interested, you can browse YouTube for some video which will suggest that what is the rate of generating this text data. I mean, it is enormous. I mean, I have some data which is like around 2 years back, which is huge. I mean, we cannot process even 1% of the text data that is being generated. So that is the challenge, right? That we got a lot of text data, and this all this text data has got a lot of useful information, right? People use text to communicate, to express their views, sentiments, and use text to translate from one piece of text to another in other some other language. So I mean, there are lots of tasks which is being carried out continuously and with a vast pace. Let me give you some example so that the idea of this lecture and discussion should be should make sense a lot, right? And you can start your moving your mind in this direction. Right? So, so I, so on this screen you can see like there is a mail. There is a mail which um, I'm asking that whether this mail is spam mail or non-spam mail, right? So, is this spam? Right. So I mean, I think you're familiar with. I got your contact information, blah blah blah. I send you this letter, solicit your partnership, transfer some money, which is like this use money, and yeah, if you can help, you can get some part of money or the whole money or sources. I mean, you know that this is a spam mail, right? They start with some text, and somewhere in between, while you read it. Now, interestingly, can you write a program which can identify that this piece of text is actually a spam? There another problem is like you got some reviews, feedback for let's say movies or some product reviews on Amazon or whatever, right? And you get this kind of text like one person write unbelievably disappointing. Another person writes is full of genuine character, richly applied style, and some great plot twist. And then somebody else writes some other comments and so on and so forth. I mean, there are so many people writing so much of like sharing so much of sentiments. Now, if it is a new movie, I mean, definitely we are interested to know whether we got positive sentiments about it or negative sentiments, and even if we would like to go into more detail of like if it is a drama movie or action, so how good is like it is rated on an action movie or those and so on and so forth. And you see, it's all about like people who are watching this movie and sharing their feedback. So, can we write a program which can take those reviews or feedback and can tell us like more correct story about how people are liking about this? So you may get like some of the people are talking about in a positive sense, like consider the movie as great, and somebody is like ridiculing this movie. So I mean, but then overall, what is the picture that is going to come out? And you don't have that much time reading all those feedback. I mean, it's like millions and millions of feedbacks are coming continuously. So can we process this kind of text? So you see, I mean, this is a negative review, this is a positive review, another positive review, and a negative review. So you see, for different reviews, you will get different kind of reviews. So the problems that we would be like covering in our talk and our discussion is like text classification, right? And you can think of like it might be like finding out the sentiments or the genre of the movie, right? Or maybe there is a piece of text and we would like to find out that on what topic this piece of text is based on, right? So assigning topics or categories, right? Spam detection, and like people write text, right? So can we find out that who has written this letter or this article or this piece of text or this mail or whatever? So authorship identification. I mean, without explicitly knowing about that who has written this mail, can you tell that possibly who might have written this mail? Right? Age and gender identification based on their writing or the text that has written by them. Language identification, kind of like language used, right? Which language, and there can be, I mean, you know that there are many languages used in communication, and they have slightly different dialect also, and at times it becomes difficult to figure out that exactly what language it, so that if you need to translate it, it is important to understand that what language, exactly what language and the dialect it belongs, and the sentiment analysis kind of problems, and many more. So basically, what we will be discussing about how we, let's say we have a piece of text. Can we attach some kind of tag? Can we put some kind of tag, some kind of like class on this tag, on this text, right? This is the problem we are going to discuss. And at any point of time, if you have any question, please feel free to ask. Right? It is important to like, yeah, ask at the same time immediately, other rather than you will forget and maybe we will lose the context later. So there is no issue if you have any question. So the basic idea of text classification, which where we will formulate all problems, whether they are spam filter or sentiment analysis or author identification, we are going to formulate all this problem in a very similar way. So what we are going to do is like, let's say we have a piece of text. So when I say document, you can consider it's a piece of text, right? So we have some piece of text and we have a fixed set of classes, right? These classes are not the are nothing but the target tags, target labels, right? So for example, there is a review, we want to say that it's a positive review or negative review. So positive and negative is nothing but the classes in which we are going to put this document, this piece of text, right, and classify accordingly. So the problem is we have a piece of text and we want to know that what tag we can attach to that document, what class we can attach to that document. So out of the known number of classes, so we know that possible classes, right? For example, possible outcomes in sentiment analysis may be positive and negative. So there are two outcomes, right? If a piece of text representing a review, it can be positive review or it can be negative review. Or you can have three classes: positive, neutral, and negative. So there, then C1, C2, C3, and up to CJ. I mean, there can be three classes. So, so whenever we interested to solve a problem, I mean, this is basically the formulation of problem. How do we formulate? So, number of classes in which we are going to categorize this document is going to be known beforehand before we solve this problem, right? So obviously, this is part of like defining problem that we know that out of these possible classes, given a piece of text or document, what class I'm going to assign, what class I'm going to like assign to that document. So that's the output, a predicted class, an assigned class C, any class which belongs to C, this set of all possible classes. Right? So that's what the output is. So this is the basic idea, right? And when we will discuss about text classification problem, you'll find that a very powerful idea, powerful approach to solve this text classification is using knife-based classifier or knife-based approach to solve to find the classification. So before we dive into knife-based classifiers or this approach of classifying text, like, let us have some basic idea behind that how it works, right? It's a very simple idea, simple classification method, which works on Bayes rule. So what is Bayes rule? Those who are familiar with probabilities, probability in mathematics, probably, and they might be familiar with that there is a Bayes rule of probability, and we are going to use that rule. That's a very simple rule. It's basically a rule to connect uh, multiple random variables, right? So basically, in a sense, they compute the joint probability of more than one random variable happening together, right, or one after another. So basically, Bayes rule is like a conditional probability rule, which we are going to discuss. And it's going to rely on very simple representation of the document. So document or the text, if I say specifically, right? So whenever I say document, you should be, I mean, not puzzled about like we are talking about whatever text and we want to label that text. Now the representation of that document or the text is going to be, we are going to represent that as a bag of words. So BOW, something very simple idea where we represent a document in terms of it's a collection of words, right? Where the order of words are not important, and the words which may have, there may be some word which will be hard or which will be very difficult to assign some kind of label. They might not be actually inclined toward any particular class, which we can say, okay, no polarity words. They can be removed from the bag. Now, how to identify all those words and remove, we'll discuss it. And another thing that we are going to consider is like words are independent of each other. So the words which are occurring in the document, our assumption is that they are independent of each other. That means any occurrence of any word doesn't influence the occurrence of other words in that document. So, in that sense, words are independent of other words in the document. So, these are the basic assumptions or basic idea, very simple idea that is going to help us to solve this problem. So consider this review. We have this like, I love this movie. It's sweet, but with satirical humor. The dialogue is great, and the adventure scene are fun. It manages to be whimsical and romantic while laughing, blah blah blah. So that is like some movie review we are looking at, right? And what we are going to do is we are going to represent this piece of text, which is like we can also call as a document, right? Text document, using this idea of bag of words, right? So how do we going to represent this piece of text as bag of words? So again, the idea remains simple. What we are going to do is we are going to identify some non-trivial words which sounds like, which supports one class over other class, right? So which has some polarity. So for example, love is like a favorable idea, is like positive sentiment words. This and I, something is like it may be may appear in positive reviews as well as it may appear in the negative reviews. So the movie, we are talking about the movie. So movie is again a non-polarity word. So when I say a word is polarity word and non-polarity word, so when I say polarity word, that means it may be towards positive side, it may be towards negative side. Means this occurrence of that word suggests some hint towards this whole sentence being a positive review or a whole sentence being a negative review, right? So, for example, sweet is like a positive word, satirical, great, fun, whimsical, romantic. These are the terms you can say. Recommend, several, happy, again. I mean, The point is, like, how do you know that these words are positive or whatever, like the words which has occurred? So how do you know that some of the words we can call as having positive polarity, some of the words are having negative polarity? So how do we know at the first place? Now, some of you may answer this that since you are familiar with all these words and their meaning, so it's not difficult to figure out that these words are actually positive or negative. But the point is, how a program going to consider that as word as positive? I mean, sounds like a positive and more positive, right? Or a word is more negative, right? Or a word is neutral, or a word like having equal probability of occurrence of in positive reviews as well as negative reviews. So, for example, this but or with or is or and or the, right? All these are like at, it, to, anyone, I would, right? Just so why or how um, a program can figure out that there are words which is of no polarity, there are words which are like positive polarity, and there are words which are negative polarity. So if I ask you to write a program which will take a piece of text and will identify me that okay, this word is more positive or this word is more negative, right? Or this word is kind of neutral, right? So how would you write that program? I mean, can you think of writing program if some of you from computer science background and they've done programming? Just think about it that you will take a piece of text, just like this review, as input of the program, and going to tell me that which word is positive, which word is negative, and therefore how simple this idea is going to be. I hope those who can program they can answer this question. Anybody would like to answer here?
Dear participants, if anybody having any idea, maybe it's wrong and it may be correct, please share with us, sir, please.
I mean, just it may be wrong. I mean, don't worry about it. I mean, it's about like maybe guesswork and maybe like you're trying to think about it. So the problem that I've given you, again, I repeat that consider this piece of text, which is like this movie review, which is shown on your screen. So you are going to take this text as input in your program, and you're going to identify all words in this program and with their polarity, whether they sounds like more positive or they sounds like more negative. So can we write a program? The question is this. I mean, you can answer yes or no, and maybe you may provide some rationale behind that why you say no or why you say yes. I mean, this is very fundamental to text classification. If we can understand this, then probably many applications which is like fall under category of text classification, they can be understood that how we solve these problems. Okay, I mean you don't want to say anything. Okay, no issue. But I can tell you, right? It's a absolutely hard problem. It's impossible to write a program simply by which will take a piece of text and I will go through in this program word by word, and if I can tell you that which word is positive, which word is negative, because there are so many words out there, right? And how I am going to do that? One way of doing it, maybe some of you may say that, okay, I have got the whole English vocabulary. And what I did is like I have stored this vocabulary with each word as designated as positive or negative. So that background work, that hard work, I mean, you might have already done by by writing, by assigning each word as positive or negative.
Sir,
So,
sir, if you refer and in the chat box, the participants are writing their response, sir.
so
Yes, sir.
okay,
Actually, like muting and then speaking all at once it is difficult. So that's why people are trying to answer the questions on chat box only. So please refer chat box as well, sir. I request, sir.
Okay, okay, no issue. But let me see if I how I can. Yeah, the point is like when I have this full screen. Yes, they are writing so many. Yes, yes, that's great.
Sir,
So
when you have a full screen, sir, you go at the top and the participant and chat window will be there. Could you please try it? You share the screen, sir?
okay, let me try because I don't use this WebEx, right?
It happens, sir.
Now we are using Zoom, so I'm not very clear
Yeah, yeah.
about that. How
So when you
so?
go up or down, there will be a one straight line, one menu will be there, chat and participant will be there.
But I'm not getting this for some reason. I don't know. Uh, my screen, I'm
Uh,
not getting.
so
When
where
I
you can control your camera, like when you where are you
so
able to
that,
see the your,
so absolutely nothing is visible when I go as a full screen.
Yes, yes, sir. It may be possible because you are using this one MS Office. So here, once you
Right.
will click on the full screen, you won't be able to see that screen, sir. So better to
Yes.
like, yeah, better to like minimize the screen and then use it on a half screen, sir. If you can do so, yeah.
Okay. So maybe you're saying that if I go by this way.
No, but now we cannot see like that PPT. You start presenting only, but on a half screen. Don't make it full screen.
But when you present it, I mean, you're going to make it a
Yes.
full screen only.
Mm.
That's it. Can you see
yes
my
sir, no
slides?
No, sir.
no sir, your slide is not visible. No issue, sir.
We will
I
unmute
will
and
read
we'll
the
speak, sir. No
I will
issue, sir.
read the question. I will read the question. No issue, sir.
Just a minute. Let me see. I was trying to only share a part of my screen, but I didn't get that. I'm not getting that PPT also like here if it is should be available what to share because in Zoom I mean you can see all the applications and you can share any particular window
So
but
it is also available such kind of things also possible
but if
here.
I see in the window there's like only Zoom cloud meeting which is visible only right and entire screen it's giving me only one option entire screen.
No issue, sir. No issue, sir. You continue. They will ask a question. I request to participant, if you have any question, please unmute and ask one by one. That will be good for us.
Yeah, that would be great if you can unmute
Unmute it.
and mute again after answering. Obviously,
Yeah.
this is a good idea.
Sure, sir. We'll be
When
following
you
that
share
only.
screen, you please continue, sir.
Thank you, sir.
Okay, okay, okay. So what it does is like when I share, it is asking only to share screen, but not a particular window. So for example, now you might be able to see my PPT, right?
Yes, sir. Yes, sir.
Yes. So okay, let's continue, and it's great that the participants are answering and thinking about it. So the idea is like it will be very hard to answer here. I mean to take this piece of text and answer that what word is positive or negative. I mean it's very hard. Even if like we try to take the dictionary, I mean all the dictionary English dictionary word and try to put that what word is positive or negative, but then that will be a very ridiculous kind of solution because there are like maybe 4 crore of words. I mean, you have to identify each word as like whether it's a positive polarity or negative polarity. You have to tag that. And even if you do that, I can tell you right, in some cases, in some application, some of the word which you have hard coded as positive might be sounding as negative in some specific applications, right? So it's actually a hard problem where I can make each word as positive or negative. I mean, it will be not a good idea that if I hard code this and attach this information with each word in the dictionary. That's not a good idea. We have a better idea, and that is what we are going to discuss. So what we are going to do is like we are going to take this document or this piece of text as a bag of words, and all those words which is like here is highlighted, which will be going to be included in the bag of word, and the rest of the word are going to be ignored, right? So obviously the question is like how you know about that, whether this word is a word to be included in the bag of word and these words are not to be included, right? So how do you know that which word is to be included? And we'll come back to this point, right? So let's assume that we got some way of identifying that what words should come into the bag of word, and then we can count that how many times, right, a particular word is appearing. So for example, great has appeared 2 times, love has appeared 2 times, recommend is 1 time, and blah blah blah. So we got like all this word and how many times they have appeared. So backup word in a sense like will tell me that what words has occurred and how many times each word has occurred in that particular document. So now I can create a word vector, which I can call as word vector, which will be nothing but the dictionary. I mean, your dictionary like words. So it may be like the dictionary of words, and wherever like that word, for example, this is the place where the great has will come. So whether it is there or not, if it is there, then how many times it has occurred? 2 times. And this particular word, whatever the other word is, the excellent has not come. So this has come zero number of times, and so forth. So I can actually create a word vector of size, which each of these word vector is going to be like size of the vocabulary, and that word vector will have indexed by all those words in the vocabulary, and we can put the number how many times that particular word has occurred in that word vector, right? Obviously, this is not a very useful idea for the reason that this can be your dictionary can be very large. So there are ways to compact your representation, word vector representation. But in a simple sense, like you may understand that okay, I can represent a document using a word vector where all those words which have appeared in the document are figuring out as the number of times they have occurred in that document, right? So if they didn't occur, then it's a zero, and if they occur like 1, 2, 3, 4, n number of times, so I'm going to put that particular cell or element as n, like 3, 4, 5, or whatever. So this is how I can represent the word vector. Right? Now, what may happen is like, for example, when you go and classify the document or the text, so whenever we are using the document, the text, we will be like entering the text. So what we can do is like we can convert each document as bag of word, and therefore what may happen that we might be having let's say this is a topic classification problem where we are going to attach a topic label for each document. So what we have done is like we have created a topic vector for each topic, right? So for example, machine learning, a machine learning document typically, I mean, they have these kind of words. So many other words. Similarly, NLP, they have these kind of words, and all these like non-trivial words. And so, for example, another topic, always collection, and that has another set of words, right? So what may happen that I have a new document, and then what I need to do is like I need to put this document in a particular bin, whether this document belongs to this class, this machine learning, or the NLP, or the garbage collection, or planning, or GUI, right? So which topic this document belongs to, I can put, right? So the idea is I'm going to somehow compare all these bag of word corresponding to this document with this bag of word for which is corresponding to each topic. Now this can be considered, this kind of like topic bag of word can be considered as like a universal uh, big bag of words corresponding to each topic, and based on whatever like words are coming in a particular document, obviously you may understand, like, okay, it's a more of like how close these words are to some particular topic. I mean, how close these words are occurring corresponding to a particular topic in terms of like all those words which are included as a bag of word for these topics. Right? So this is how we can find out that how close these words are, and therefore that is going to correctly get inserted in the that means correctly labeled with the corresponding class. So these are the class labels, and this is what we are going to do. We are going to create, in a sense, like a representative like text, representative text or bag of word vectors for all those topics, right? For all those like classes, and then we'll compare all these text here in a document compared to like this text here or this text here, and whichever is like going to be closer, then I'm going to assign them. So I hope that you understand this. So bag of word, right? Idea is very simple. This is another example. Let's say we got review one. Movie is very scary and long. This is like movie is not scary and it's slow, or movie is spooky and good. So you see, we got these three reviews. Just as a like simple example. So here review one will. So what we are going to do? We are going to create a vocabulary. Now what this vocabulary is going to be nothing but the collection of all words which have occurred in all those reviews, right? So basically, this vocabulary is not an English vocabulary per se, but whatever data set that we are going to use. So we are going to extract this data and extract the words which have appeared in any of this review, and therefore our vocabulary will consist of all those words, right, which has occurred throughout in all those reviews, and that's going to be a smaller subset compared to the dictionary size itself, right? So now this is the vocabulary which I can say, okay, this is the set of words in our reviews. Now you can see, like in the review one, which word has appeared. So for example, this has appeared one time, movie is appeared one time, is appeared, very appeared, scary appeared, and is also appeared, long has appeared, but then the other words has not appeared, right? So they are going to be zero. In the similar sense, we can work out for the review number two. So what word has occurred? So for example, is has occurred twice, right? So that is we are putting two, and the rest of the words are like one or zero, depending on how many times they have occurred. And similarly, review three, review four, review five. I mean, we can do it for all those reviews. So that is nothing but what we have got. What we've done is like we have represented each review, each text, each piece of text, or each document in terms of bag of word model. So this is one interesting way of representing your text, right? It's a kind of like you have extracted the features from the text and you represented them as vectors, right? So this is a vector, right? This is one vector. It's corresponding to review one. This is another vector. What this vector is suggesting, whether this word, that particular word index in that location, for example, this has appeared how many times in that review, right? So if it has appeared none, so it will be zero. Or if it has appeared 1, 2, 3, so then these cells are going to be marked, or these elements are going to mark accordingly. So what this data set, so this becomes a data set, and I hope if you know machine learning, that how we solve problems in machine learning or classification problems in machine learning is nothing but we require a data set. So what we are doing here is creating a data set out of a text data, right? So we have got the text data, text, for example, movie reviews, and now we are creating a two-dimensional matrix where each row corresponding to one instance, one review here, for example. And if it is a classification problem, then you know that we are going to attach a label. So one more column that we are going to add here in this table, which is going to be the class label. So that class label is going to be, like, for example, this review is negative. The second review is also negative, and the third review is positive. So we are going to have like their strengths, right, and their labels. So for each instance, and the label is also attached to it. So this is nothing but the data set that is now ready for you to apply those standard machine learning algorithms, right? And we will apply naive-Bayes algorithm. We'll see that how we can use or apply naive-Bayes algorithm to solve this problem. Right. This is backup word is a very simple idea where each word has occurred how many times we put them. But there's another very useful idea where we can compute not just their frequency, but in the sense like that how a particular word is more meaningful to a given document and not that common to other documents. So basically, this idea, which is called TF idea, term frequency and inverse document frequency, these two terms, which will be used to calculate an indicator which will suggest that how good is this, how useful this word is compared to if we compare other words with other documents, right? So how a word is more useful or more relevant to a given document, right? So let us discuss. This is again a simple idea, but very useful idea. So this TF idea, this consists of two terms: TF, term frequency, and the IDF is inverse document frequency. Now, term frequency is nothing but a kind of indication that how prevalent, how useful, or how important this word is with respect to a given document, right? So a word is more relevant and more like significant to a given document if it has occurred in the document and maybe multiple times. So more number of times the word has occurred, more relevant is that word to that document, right? And in a sense, like that word become a kind of defining word for that document, right? So for example, this word compiler, right? And if there is a document which is having this word compiler multiple times, it's more likely that this document is talking about compiler, like it is relevant to the compiler. So we may got some kind of hint that yeah, this is from compiler domain. So maybe more likely that this document may belong to like it might be talking about something related to compilers, right? Or any other similar kind of word which might be occurring multiple times. So there is one thing that we will also be taking care of to make the whole process more efficient is that there are words which is very hard to suggest that they can be defining words. When we say defining words, for example, the example we taken in movie recommendation, and there you have seen that we have only picked a few words and ignored many other words for the reason that the other words do not really represent the polarity, right? In other words, what I can say that these words, which are not important, they have equal probability, equal chances of appearing in all classes of document. So if we are talking about movie reviews and the reviews of kind of positive reviews and negative reviews, so those words have equal probability, more or less equal probability of occurrence of positive review as well as negative reviews. So these words are not defining words, right? And they are simply adding up on our computation, right? So I mean, if I'm using that word in my like bag of word, then I have to compute, right? The number of times they have occurred, and this computation I can avoid by removing that word, those words altogether. So this normally what we do in text classification, that whenever we go and classify some piece of text, we remove these words, and these words are called as stop words, right? A term which we use, the stop words, right? So stop words are those words which are called non-polarity words also, right? So these are the words which are have equal chances of occurrence of in any of this intended class, any of the targeted class, right? So if we can remove them, then our computation can drastically be reduced, right? So number of computations that we will be doing can be reduced, and that will be helpful step if we remove stop words, right? So, so what we will assume that all these computations that we are doing we will be doing only on those defining words, right? And therefore, each document will be having some words, and hopefully these words may be defining words for those document. So a word which is coming more number of times might be more defining to that document rather than a word which is coming less number of times. So the idea is simple, that how many times term frequency and how many times a word is occurring in a particular document. That's a term frequency. And this is a simple idea. We compute the number of times that word has occurred, divided by the total number of words in that document, right? So that will give me a fraction which will suggest that if the value of this fraction tf t comma d, like given that particular term and in that document. So this is relevant to a particular word for a particular document, right? So that's why the term, that is the word, and d is the document. So what we are computing is like the term frequency for that term t, given that particular document, is the number of times that word has occurred in the document divided by the number of terms in the document. And this is going to be, if this number is high, that means that word has occurred more times, and there's like a significant word, maybe a defining word, possibly a defining word for that document. That's a term frequency, right? So this here is an example which is given here, and you can see, like, for example, this review number 2, right? You can see like this has occurred one time out of 8 terms that has occurred. 1, 2, 3, 4, 5, 6, 7, 8, right? So 1 by 8, and this movie is like 1 by 8 again, and this is how we can compute term frequency TF, right? Now, what is IDF? IDF is a measure of how important this term is. So a given word is important to a document, and if it is not that important to other document, the point is like that particular word has occurring more number of times in a particular document, but occurring less number of times in other document. And that's why this, so inverse document frequency is nothing but a measure which will suggest that how likely that word is occurring in other document also. So if it is likely that that word is occurring in other document as well, that means this word is not a defining word, because it has a tendency of occurring on different documents, all those documents, right? And therefore, this is not a polarity word or a defining word. Right? So how we compute this idea? We take a fraction. We got this number of documents. We know that number of documents, and right? So number of movies reviews, for example, we would be knowing about this data, and the number of document which is containing this term. So you see, if this is equal 1, that what does it says? That this particular word, the word T or term T, has is occurred in all the documents. So that the number of document divided by the number of document with term T is 1. That means that term T or the word this T has occurred in all the document, and therefore the number of document divided by again the number of document is going to be 1, right? And if we take the log of it, then log 1 is 0. That suggests that this is really a poor indication that this word can be a defining word, right? So 0. So IDF. So that's why this we can take the log of it, and if it goes to 0, that suggests that it is not a very good word. So eventually, what we are going to do, we are going to actually multiply these two terms. TF term, which is like the term that we compute what the term frequency, and that second term will come from the um, inverse document frequency, IDF term, right? So TF term and IDF term, these two are multiplied. So you see, if it is 0, then this value is going to be 0, right? Or if this value is close to 0, if it's not 0 but close to 0, still this term is going to be close to 0. And therefore TF IDF, right, this value suggests that how important that term is in defining document. If this is high, when this will be high, when this term is not coming in many documents, but the term is coming in few number of documents, maybe like one or two, a very few number of documents. So the number of document might be very large, total number of document, total number of views, and that particular word is coming in the one or two or three, I mean, few number of documents. So this ratio, which is like number of document is n, let's say, and the number of times like it has come. So if n is very large, it's very large, so that this ratio is large. And if this ratio is large, that means this value is going to be large, and this is also like so we are going to get a larger value here. So what it indicates, a large value of TF-IDF suggests that that particular word is a defining word, because that word is occurring in a particular document, particular type of document, and not common to all other documents. So therefore, that particular word can be a defining word. So wherever in a document we see that word, it's more likely that the document is going to belong to that class rather than any other class, right? Obviously, the problem is not that simple, because there will be many words. Some words may be occurring in some document, and some word may be some other document. So obviously, this idea is not going to be that simple, but then definitely it gives us a clear indication that if a particular word occurring in a particular document, and if it has a high value, very high value, highly like positive, then it's more likely that this can be a defining word. And if it is close to 0, right, then this may be not that defining words, right? So this is how. So this is another way of like computing this. You can compute. So for example, if you use bag of word, you will get the word vector as this, right? This is for the second review, and this is for the third review. But if you use TF-IDF, excuse me. So if you use TF-IDF concept, then you're going to get this vector is replaced by the vector of like numeric numbers, right, which is like zeros and non-zeros terms, right? And they might be more useful term, because here it captures like some number, but here this not only captured the number, but also like connected with how likely that word is occurring in the other document. So the numbers computed here are more useful. You can say provide more information about that, how good that particular word can be, if we are interested to find the defining words for a particular class of document, right? So TF-IDF is considered as a better idea than this simple bag of word representation, where we represent each occurrence of each word by their frequency, simple frequency. But here, this TF-IDF is a more complex expression, which suggests that not only it captures the idea that that word has appeared in the document that number of times, but it also captures another component, that how common that word is compared to other document, right? So higher is this number, higher is the possibility that this word has occurred in this document but not occurred is rare word for the other document, right? So this data is more useful compared to this data. I hope this point is clear. If you have any doubt here, you can ask. So we can actually use, rather than these kind of vectors, we can use these kind of vectors to do our calculations and to solve those problems. So this is important, right? To create your data set, whether you create your data set using the simple 1, 0 or like simple using frequency counts, or if you create your data set using TF-IDF, it is important because this will definitely have some burden, some good implications in solving problems. So let us like move to that. How do we solve this problem? Once we now know that how feature are extracted from text, right? So now we have got our data set created. So feature vector is extracted, and we so data set in the machine learning sense, you know that it's nothing but it's a two-dimensional matrix where we have got like this columns, and these columns are nothing but the attributes, right? And we have got the rows. So this is like movie review number 1, movie reviews number 2, 3, 4, 5, 6, and all these are nothing but these are the input vector. And then finally we have a column which is called the the class label, the right. So here we are going to put a positive or negative, positive, positive, negative, positive, negative, and so on and so forth. So we will have, let's say, maybe 10,000 reviews, right? All the like 1, 2, 3, 4, 5, 6, 10,000 reviews. And for all these, we know that whether they are positive or negative by knowing their labels, right? So we got this data set created. So at this point of time, those of you among you who are from machine learning background, I mean, they know about how to solve problems using machine learning. They will be happy. They should be happy in terms of like they got a data set which is very familiar to them. I mean, now they know the data set. They can use the data sets to get apply any machine learning algorithm and 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 solve this classification problem. Now this problem is in the form of a classification problem where we got a labeled data set. This is called labeled data set, right? Which has got the input vectors, the output label, and for all the instances we got this information already available. So we got a labeled data set. So what we are going to do, we are going to now apply this Bayes rule of probability, which is a very simple idea. Again, those who are familiar with probability, or even if like so the idea is like we got a class C, a document D, and if you are familiar with the probability or the joint probability formula, let's say if there's like two random variables C and D, right? C and D, and you want to compute the joint probability of C and D, then you know that we can compute the probability of C multiplied by probability of D given C, right? That's a conditional probability. So what it says that what is the likelihood or what is the probability of occurrence of both events C and D, right? So what it says that okay, it is equal to the probability of occurrence of event C multiply the probability of occurrence of event D given C has already occurred. So that's the conditional probability. This is a conditional probability. What it says that probability of occurrence of D given C has occurred. And equivalently, we can also compute this as the probability of occurrence of D multiplied by probability of occurrence of C given D has occurred. So any event that might have occurred earlier, so these two are very equal kind of formulas, right? I mean, they are equal expressions. So when you equate these two expressions, you will get this probability of C given D, this equal to the right hand side divided by this term which is multiplying here, but then we'll go the opposite side, then it will be going to the denominator, and therefore you got this formula. So it's a very simple idea, right? Again, very simple, that the probability of occurrence of C given D equal to probability occurrence of D given C into probability of occurrence of C divided by probability occurrence of D, right? So it's a very simple probability rule, and which is like this is called a Bayes rule, right? What it says, Bayes rule is a conditional probability rule. So what it suggests that event, the probability of occurrence of event, given that any other event has occurred. So there is some kind of conditional dependence, and that's what is captured by the Bayes rule. That the probability occurrence of C given D equal to probability occurrence of D given C into probability of C multiplied by probability of D. Sorry, divided by probability of D, right? So this simple formula is nothing but called as Bayes rule, right? Bayes rule of probability is a conditional probability. Now, how we are going to use this? So here C stands for us, C stands for class of the document or the label of the document. D is stand for the document. So what it says, the given a document, what is its label? That's what we are going to do, right? The given a email text, right? New email. Now, whether I should be called this email as spam or non-spam, so that I can put it in the spam folder or on my inbox, right? So I'm going to I'm going to attach a class label, and this class label, so it can take a class label as spam, and it can also take a class label as non-spam, because there are two possibilities. So here, what I'm going to do is I'm going to compute these two. I mean, this formula or this value, this probability for both classes at one time, like for spam classes and for non-spam classes. So what I'm going to do is like I'm going to compute P of C equal to spam given the document is already given, document is text is already given, and I'm also going to compute this C equal to non-spam given the document. So I'm going to compute these two probability, right? And whichever probability is high, right? Since I'm going to get these two probability, I can compare these two probability. If one probability value is high, for example, a spam probability value is high, I'm going to label that document as spam. It's a very simple idea. What I'm going to do, I'm going to use this formula, which is straightforward formula. I'm going to compute this term, which is the probability of C given D for all classes, C1, C2, C3, C4, for all classes, and whichever is going to give me the highest value of the probability, I am going to assign that document that particular class, right? So I'm going to assign that. This is the prediction. This is the machine learning task that I'm going to do. But now, having said that, I can do this, but then what I require this term. To compute the left-hand side, I require the right-hand side, right? So I require this term, I require this term, and I may require this term also. But I can like leave this. Why? Because this is a division factor, right? And it is dividing each term, right? It is dividing the numerator. So this is, if this is the constant, right? Because it is the same value every time, irrespective of whether it is C1 or whether it is C2 or whether it is C3 or whether it is C4. So whatever C we choose, P of D is like P of D is constant. So that's a constant term. So since we are going to compare which one is going to larger on the left hand side. So this larger will remain larger because it is being divided by, I mean, this numerator is divided by this constant term. So if it is a larger term, then it will remain larger because that's a constant term. So what we can do, we can get rid of this. We can only need we need only these two terms, P D given C and P of C. Now, how to compute these two terms? If we can compute these two terms, I can compute this, and therefore I can compute this left term for all classes, and therefore I can find which is the class to which this document should belong to. So that's what the going to be the base classifier. We'll come back to this naive term. So why it is called naive base? But I think now you understand that it can be called as base classifier, and obviously I need to explain that why it is naive. So for now, what I'm going to do, I'm going to compute this value, because this I drop, and I'm going to compute this, and whichever like C give me the highest value of this multiplication, these two terms, right? I'm going to take that as I'm going to assign this C map, that is the maximum a posteriori probability. This is the name of this term, C map, which is nothing but which is the class label going to be assigned to that particular document, is nothing but which is going to give me the highest value of this multiplication among all possible classes. That's what the idea is. Like, so map stands for maximum a posteriori, that is the most likely class, and that is what I'm going to assign. Now the point is these two terms, right? We need to compute P of D given C and P of C. Now D is document and C is the class, right? So how can we represent this document? We can represent this document with the bag of words, right? So now comes the idea that we discussed earlier, that where the bag of word is going to be used. So all this x1, x2, x3 are nothing but the terms or the words that we have extracted from that document and represented. So P, x1, x2, x3, x3, x4, xn are nothing but those n terms that we have extracted from this document, right? And remaining things remain the same, right? This is C and P of C is the property of this class, right? So I hope that still you are following. So a document is nothing but is represented by this feature x1, x2, x3. This is nothing but the bag of word features, and that's so what. So what we need to do, we need to compute these two terms. One is this term, and another one is like P of C. And you will see that how we compute these two terms. And once we can compute these two terms, we can compute for all C these terms, and therefore we can compare and can find for which C we got the maximum value of probability, and that C is going to be assigned for as a class label for the document. Right. So this we have already discussed, that bag of word assumption, that the position doesn't matter. The word may come earlier or later or anywhere in the text. We are not looking at the order in which the word is occurring. So that also allow us to have this assumption of conditional independence, that the words are independent of each other, right? So when the words are independent of each other, this term, right, P of x1 to x2, x3, when we say that their order doesn't matter, x1, a particular word can be here or anywhere, like it's just a joint probability where the word occurrence can be independent of each other. So the order doesn't matter. When we say, that means they can come in any order. That means if we try to compute the joint probability, which is the conditional probability of all these, like all these words, occurrence of all these words, you will find that it's nothing but P of x1 into P of x2 to P of x3. Obviously, there is C here, so that C will remain here, and so forth into P of xn given C, right? So this formula, this measure becomes very simplified. It's nothing but the joint probability or multiplication of the probability uh, of occurrence of all these words independently, obviously given in that document. So this condition on that C, again, that can be taken care of by simply considering that a global document, a very big document which contains all the like words which has occurred in that particular class of documents, right? So since we have got the positive reviews, we have got the negative reviews, so we have got like two classes of documents. So here C, that CJ is nothing but going to be at one time the positive class, another time is negative class, only two classes. So C1, so CJ is like, J is like 1 and 2, right? So one class is positive. So C1, let's say, is positive and C2 is negative. So that is what we are going to do. So what we are going to do, we are going to compute a global document, a very big bag of for all positive reviews, right? So what I'm going to do, I'm going to combine all positive reviews together and make a very large, big global single document which consists of all the positive reviews, and that is going to be my class C1, let's say, and the C2 will be nothing but the class where all the reviews, the negative reviews, we will combine them and create a very big global document. So now this is these global documents are representing whether that word has occurred in that document or not, right? So computing this will be then straightforward. What you need to do, so this part, like this is multiplication, right? So multiplying all this property, x, that is the number of times the x has occurred, or different values of x, all those x, right? Given this this class, so this you can compute p of x1, let's say, given c1. This you can compute that the number of times the x1 has occurred, and divide by the total number of terms in C1, right? And this is also in C1. The number of times x1 has occurred in this global document C1 divided by total number of times, total number of terms in that C1, right? So that's nothing but P x1 given C1. So similarly, we can compute P x2 given C1, P x2, x3 given C1, and all that. And similarly, we are going to compute P x1 given C2, right? Two classes, right? P x for x2 given C2, and so on and so forth. So we can compute this, and therefore we can compute this whole. Now, what about the P say CJ? The probability occurrence of CJ. So since how many documents you have? Let's say you got 10,000 reviews, movie reviews. Out of this, like 5,000 are positive reviews, another 5,000 that like negative reviews. So what is the property of C1, like positive reviews? So P of C1, let's say C1 is positive, C1 representing positive reviews. So P of C1, it will be nothing but 5,000 reviews. There were number of positive reviews, and there were total number of reviews 10,000. So this is like going to be 1 by 2. So if the data set, your data set is balanced, this probability is going to be divided equally among all those classes, right? So it's like there are two classes, and we have got equal number of instances of both classes, then PC1 equal to PC2 equal to 1 by 2. If there are three classes, then this is going to be 1 by 3. Each is going to be 1 by 3, right? If it's like four classes, each is going to be 1 by 4. That's because they are going to have equally divided, right? So like if there are four classes out of 10,000 instances, that means 2,500 instances of each class. So 2,500 divided by 10,000 for each class, we are going to have 1 by 4. So computing this and computing this, we can now compute this whole term for all classes C1 and C2. For example, for binary classification, there will be two classes. So CJ is going to be C1 and C2 only, and therefore you will compute this term. You know this part, you know this part also. You can multiply all this, right? and compute for C1, and then you can compute for C2, right? The same term, and then you can figure out, okay, which one is going to be a which one is a higher value, and corresponding to that is the class going to assign for the document. And that's what we call as naive Bayes. Now, why we call it naive, right? We call it naive because this joint probability with the assumption of conditional independence will become like a multiplication of this probability usual occurrence of each of this term in that document, right? So that assumption that the occurrence of all these terms are independent of each other, this independence assumption makes it a naive assumption. This is called a naive assumption, right? So that's why we call this not MAP, because like until unless if this assumption is not made, so most general form it is C map. But if we make a naive assumption that the occurrence of all the terms are independent of each other, then we have this class which is going to be assigned because of this strategy, and therefore this C, like the class is going to be like C naive Bayes, because that is obtained by the independence assumption of the occurrence of each word or term in that document. So I hope that make things clear. How much time I have? So I have like 15 minutes to discuss this application where we will use a movie review application. And what we are going to do is like I'm going to show you that how we will work out that using some code in Python. So I'm going to take this example, which is where I'm going to use a database, movie review database, which is containing the movie reviews, both positive reviews or negative reviews. So what I'm going to do, I'm going to train a naive Bayes classifier. Training a naive Bayes classifier will be nothing but knowing about all these probability values, right? That a particular word has occurred in a particular document, particular class of document. So what is the probability of this? So these terms are nothing but the training part of the naive Bayes classifier. So when we say we are going to use a naive Bayes classifier, so what is the training here? When we use a naive Bayes classifier, training is nothing but computing of those probability values, and what is the likelihood of a particular term occurring in a particular class of document. So we'll compute this for all those terms, possible terms that can occur, right? And these probability values are nothing but the learning part of the naive Bayes classifier. So we'll be using a data set that will help to know these probabilities. Once you know the probability, then you take a new data, a new instance which needs to be labeled, new piece of text or new reviews which need to be labeled with positive or negative. So what we are going to do, we are going to compute the formula, right, for considering whether if that review is a positive review and if that review is a negative review, and we'll get the probability value for both the possibilities. Now, which one is going to be higher is going to be the label, or if we get the higher value from the positive corpus, that means it belongs to the positive corpus, and therefore we are going to label as positive. And if we get a higher probability value from the negative corpus, negative review corpus, then we are going to label that particular piece of text or the review as negative, right? So that's what, right? So consider like you got a new review, a real movie about the real people. Movie gives us a real glimpse into the culture most of us don't know, right? So whether this review is positive or negative, see, it's not. We are not asking to a human, right? We are asking this to a machine learning system which is already trained over some data set, right? So now that machine learning system will take this review and will going to provide us is going to provide us a label either positive or negative, right? And obviously, depending upon the kind of training that particular classifier had, is going to assign the positive or negative. And most likely, the training is done correctly, then it's going to answer correctly. Right? So that's what the purpose of machine learning. In the natural language processing, also, like, we can use a piece of text and apply machine learning classifier to find out the label of the text. That's what the text classification problem also reflect. So what we are going to do is, like, we're going to take a data set. So first, the training part of our solution, the way we are going to solve this problem. So we are going to take a data set. We're going to load the data set and perform some pre-processing. We'll see that what kind of pre-processing we are going to actually take out the sentences from the text, and from sentences the words from the text. So, and we may be actually removing those stop words, which is like not so useful words. So we are going to do, before we come up with a word vector for each of these movie reviews, right? So that is nothing but going to be the pre-processed data set, right? Which we now know how to create a pre-processed data set, which will be in terms of a word vector corresponding to all the reviews, whether they are positive reviews or they are negative reviews, right? So we got a pre-processed data set. So here the data set may not be like available in the form where we can perform some kind of pre-processing and can make the data set in the form in which we would like to now use it in for the machine learning task. So here, at this point of time, our data set is ready for to be applied the machine learning, right? Classification task. Now, while we apply the classification, so what we do is, like, we take the data set, we divide the data set into two parts: training data set and test data set. You know that that's the typical we do. So that's the training data set part and the test data set part. From the training data set, what we do is we build a classifier, like, or learn a classifier or train a classifier. All these terms are similar. I mean, what we are doing is, like, we are learning that hypothesis function, which is the underlying function behind the that particular algorithm. So here we'll be using a naive-based classifier. So learning in the naive-based classifier is nothing but, or training in the naive-based classifier is nothing but getting those probability values for each term, right? Whether how likely this term is going to occur in the positive review, so that P of, like, that particular term in the class C1, and the P of that term in that class C2, where C1 is like positive class and C2 is like negative class. So we are going to learn about each term for all those terms, Ti for I equal to 1, 2, like all terms in the vocabulary, right? So I in V, right? So all those vocabulary, that is the all those terms, whether they have occurred in the positive or negative or both or whatever, that we are going to find out these two probability values. Once we know these probability values, and then we know the formula for, like, computing P of, like, C1 given the document, given the, right, this we are going to compute for C1 and for C2 both, right? And you know that how do we compute this? So this is like P of D given C1, if it is 1, into P of C1, right? And P of C2 given D is P of D given C2. And D is nothing but the document, and the document is represented, as we know already, right, these terms, right? P of D given C1, and we know that it's nothing but P of all those terms T1, T1, T2, T3, all those given C1, so which is nothing but the P of C1, sorry, P of T1 given C1 into P of T2 given C1 and into. So this we can find out and substitute here, and that will give me the P of C1 given D, P of C2 given D, and whichever is the highest, whichever is the larger, I'm going to assign that class to that. That's the idea. So what I'm going to do, I'm going to build this classifier, and building the classifier is nothing but knowing about all those terms, like, right? So once the classifier is trained, that means we got all those individual terms known, right? Now we get a new reviews, real-time new movie reviews, which we give it to classifier, and it is going to tell whether this is positive or negative by by computing these two terms, right? Right, and whichever is the highest, it is going to assign me C1 or C2, depending upon which one is there. So that's the idea. Right? So the data set is given here. It's like from Cornell University. It's like 5331 positive reviews and 5331 negative reviews. So more than 10,000 reviews here, 10,662 reviews, among which there are exactly half, like half positive and half negative. And this is good, always good. Like if you keep your data set balanced. If your data set is imbalanced, then there are some other issue that will come. And generally, it's a good idea to keep your data set balanced. So what we are going to do, we are going to take reviews, those movie reviews in the data set. I'm going to tokenize. So first we are going to perform sentence tokenization, where we will identify all the sentences one by one. And after that, we will perform word tokenization, where each word from each sentence is going to be extracted. And then we are going to filter out the stop word so that our computation will reduce. So we will be dealing less number of words, and they're more likely more defining words rather than common words across all classes. So we are going to remove the stop words, and we'll remove some more unnecessary stuff from the text, which is like punctuation marks and other kind of stuff. And we may perform stemming also. Stemming will allow all those words to go to their basic form. So for example, we have like the run and running. So these two are basically similar word, right? Happiest or happy, these are the similar words. I mean, same word basically. So what a stemming does is like, otherwise, see, I mean, program don't have this kind of intelligence that it can figure out that the run is same as running. No. So what we do is like we stem. Stem means chop out some part of a word so that all those words will come into very basic form. For example, run. So all those will become run, and therefore it will be simple to understand that how many times this run has come. Otherwise, we will treat these two separately, run and running. So we may consider as separate. So stemming is a good idea whenever we are interested in basic words and not interested in their different form. So stemming will allow to convert all those words to their basic form, so that we should be able to differentiate, and we should not be confused with like whether this run and running being two different terms, which they are not actually. So we will perform stemming, and once we got our final set of words, this bag of words coming out, we can then formulate them as a data set. So this is like number of times this has come, the give has come, right? So it is like putting these numbers, and then this is the label of the class, and this review belongs to the positive. So this becomes the instance which is to be used by this machine learning algorithm, and that's what we are going to do. Like, so I'm going to show you a Python demo for this particular problem. And to tell you, like, I will be using a natural language toolkit, NLTK library, which is a very fundamental and very like useful library to process this text. There's a lot of like functions, like text processing function already included, so you don't have to write your own function. Rather than you can simply call those function and get your work done. So for example, sentence tokenization, word tokenization, removing words. I mean, you can use standard function, inbuilt function, which is provided with these libraries. There are many libraries, but this is more popular. NLTK. There are other Apache OpenNLP. There's another Stanford NLP or Mallet. These are all open source and free library available for you to, I mean, carry out NLP tasks and design NLP solutions using machine learning, deep learning. So we will be making use of NLTK, and I'll show you that how to. So let me take you to the Colab window. So I hope that you are familiar with Colab. If you have any question, I can see a few now chat window. So Vivek is actually helping me. Thank you, Vivek, providing answer from my side. That is great. So yes, text is basically in a sense like categorical variable. So yeah, the naive base is perfect classifier to deal with this kind of variable, categorical variable, which is like text variable. Yes. What is it? Sure. So I hope you can see my
Yeah, sir.
Google
It is visible.
Colab is visible, right?
Yes, sir. Yes.
Yes. Let me take a. So this is a Google Colab IPython notebook file, which is like the Python program open in the Google Colab. I hope some of you might be familiar already with Google Colab. It's a wonderful platform where you can run Python code without actually needing to download a compiler, Python compiler and an editor and those kind of things. I mean, you can take the help of this Google Colab to run your program, and that's what we will be doing it. So if you would like to have, let me share this this file so that you can also open in your browser. So it's just like you need a Google account. So if you already log in using some Gmail account, that should be fine, right? What is happening? I may have to say, perhaps reload this. I'm already connected. What is the problem? Maybe there's some issue from my side, which is. I think I'm connected with the internet, right?
Yes, sir. I think so.
Yeah, obviously we are able to interact. So I don't know why this. I mean, this Google Drive is not accessible. I don't know. But I got so anyway. I will share this later. That's not a problem. So what you do is like let's run this code. So I need NLTK as I said, and NLTK is normally not available in Colab. So what you need to do is you need to run this code, which is nothing but downloading NLTK. For the first time when you run some code, it may take a couple of seconds or 5-10 seconds to execute the first cell, and then but after that you will find this quite smooth. So it will not be a problem, right? So what it does is like it has downloaded the NLTK package for me and put it my path, my execution path, right? And therefore now the NLTK is now available for me, right? So now what I'm doing here is I'm showing that, let's say, take a piece of text. This is a piece of text which is like a movie. It looks like a movie review. And what I'm going to do is like I've stored this piece of text in this variable example text, and I'm tokenizing uh, this text. So I'm using this function sentence tokenization. So send underscore tokenize, and passing this text example text here with this NL dot tokenize dot send tokenize. So send tokenize is the function under the package which is like tokenize, and which is included in NL, right? So this, those who are familiar with Python, they should be able to understand the syntax here. I have imported NLTK as NL, so I will refer to this NLTK package at NL. So this is the NL here, right? And dot tokenize is the tokenized package within this NL. So package can contain further packages, and within this tokenize we have got the send tokenize function that I'm calling. So generally, a package in Python is nothing but a collection of functions, right? So this tokenized package contains many functions, including this function, which is called send underscore tokenize, and which takes a parameter, which is like piece of text. So I'm giving this piece of text, which is stored here. So this variable is a text variable, right? So when I run, what it is going to do, it is going to separate out sentences from this piece of text. So right now there are only 2 sentences, but it may have 10, 15, 100 sentences, and this will perfectly do the task of sentence tokenization. So sentence tokenization means separating out the sentence. So here, if I run this, I got this output. This is one sentence followed by this comma. So it provides me a list of sentences which it has identified. They are separated within the list by comma. So obviously, those familiar with Python, they should find it comfortable. But those who are not comfortable with Python, they need to just. Python is simple to read, but yes, you need to learn it before you can program. So here, this is a list represented by a square bracket, and the elements are separated by comma. So this is, so you can see like this is first element, which is a string type. So this is one sentence, and this is the another sentence here, and this is a separator, right? So there are 2 sentences that you got, and that's a print statement, and that suggests that this tokenized function has done, and we can also see that what it has done, right? It has separated out these 2 sentences, right? I can store it in some list also, and for processing, and that's what I'm going to do. So after the sentence are tokenized, I'm going to use word tokenization. So this is, for example, a sentence, a single sentence. I'm going to pass it in this function. Now this time it is a word tokenize function under the same package tokenize, which is of like from NL, which is NLTK library. So I'm using directly this function. You can see like how simple this idea is to use a third-party library within your program, and you don't have to actually write. So in fact, if you are interested to see that what is the code of sentence tokenize, how it does the tokenization, how it takes the speech text with multiple sentences and separate out these sentences, I can tell you like this is not a simple idea. I mean, if you think that these sentences are separated by this full stop symbol, now there can be many places where this full stop symbol will come, and so for example, Mr. followed by full stop doesn't mean that the sentence end here. So there will be issues, right? There will be other punctuation marks also, like for example, a question mark that also suggests that the question ends and therefore the sentence has ended. So those kind of things need to be taken care of. So this function does a lot of stuff. and will give you a correct set of separately identified sentences. And similarly, this function word tokenize will give you all those words of a sentence, right? Now, why we need words tokenization? Because we need to actually ultimately go towards coming up with a bag of words, right? So we are identifying or extracting words, and then we will do some more pre-processing here before we consider that as a final bag of word. So what we are going to do, I can skip this part. So what I'm going to do, I'm going to remove the stop word from the identified words, and yeah. So stop words, I've already explained what are stop words, right? So in Python, if you, that is already available here in the with NLTK. So there is a library of stop word, or you can say a collection of stop word already available with NLTK. So you can download that stop words, right? And mm, the these words, stop words, will may have words from many languages. So many languages, like many foreign, and maybe Hindi also, like it's going to have. So you need to provide which language these stop words should belong to, and that you need to. So those stop word is going to finally uh, going to contain the list of stop words in English language. This is just for indicative purposes. I mean, this stop word is not very exhaustive library. It's just for example. You can make it, can populate this stop word with additional stop words, which so you can make it more rigorous, more rich in terms of stop words. I can show you that what are the different stop words here, right? So here, for example, if I run this, okay, so what I didn't do actually, I run this, okay. So since this code is written in cell, you need to make sure that you run all those cells in that sequence, right? And you will find that, okay, so the stop word provided by LLDK package, when you have downloaded them, right, is, you can see like this is the list, myself down below, and if I can, you can see like there are many words, but it's not a very big list of words which can be stop word. It's just an indicative, right? So they have done it. They have given you some hint or some help, but this is not the kind of which I can consider as a final list of words which can be considered as stop words, right? So though it is a big list, but that's not that big. Which, and you may find that there are some many words missing here, which you may think of like it should also be there, and we'll see that why I'm saying so. So this is just a list of words, and what I'm going to do, I'm going to filter out all those words which are already there in this stop word, right? So I'm not going to consider them. So I will filter those words, and I'll be left with then the words which are not in the stop word. So what I'm going to do, I'm going to take those two lists, right? One is the list of stop words, and then the second list is like the word tokens, which contains the our set of words, and I'm going to apply this like, so for example, for W in word token, so for all those words in my word list, if the W is not in the stop word, then put it in the filtered word. So what it suggests, that if the word is not here, so if, so for all those words which are in my set of words, right, in my like sentence or whatever I have like tokenized. So I got a few words right in that. Now I need to know whether some of the words are stop word or not. So what I'm going to do, I'm going to iterate over. I'm going to take one word at a time in that my list of words, and I would like to search that word. If W is not in the stop word, so if W is not in the stop word, which we have seen like long list of word, then I'm going to put the W in this empty list. So I'm going to, initially it is empty, there's nothing there, but I'm going to add one by one. So all those words will be inserted which is not in the stop word. That means if the word is in the stop word, then that is not going to put here. So after that, I'm going to have a filter out word. Filter out word, that means they will be free from. So you can see before that we got this movie, us. So there was a rare glimpse into this a, this off, this us, this do. So you see there are some words now missing. No, we got movie, we got gives also, we got us, but then there are some words you can see that they're missing. A is missing, and into is also missing, I guess. Into is missing or not? Yes, into is missing, and off is missing. So missing is like they were in the list of stop word, and therefore they are not now figuring out in this filtered set of words. So we are moving towards uh, formulating or finalizing our bag of word, but still it has some unnecessary punctuation. For example, this full stop. So I can also remove that. So same with the same process. Now this here, I'm using a manually created list of punctuation here. So that's not a list of stop word which we downloaded. Rather than these are the punctuation marks which I have stored, and then I'm going to run the same idea, right? So I'm going to filter, uh, will apply another filter, and I'm going to have. So for example, this was the unfiltered list, my list, and where now the punctuation is removed. There was only one punctuation, so I get rid of that punctuation. And then I can apply stemming also, as we discussed that stemming will, this example probably do not have multiple words of similar nature or similar stem, similar base form. So so it may not give you the kind of answer that we may be looking for this example. But yes, if you can run it for, which I'm showing here. So for example, if you take this Python, Pythoner, Pythoning, Python, these are all like Python. The basic word is Python, right? Though if you don't do a stemming, then these words will be considered as different, right? So they may come in some document and some other word can come some other document, and that may clearly a kind of a confusion, right? Because these are actually the same word. For example, banker, banking, and bank. So in that set two, if you do a stemming, you will find that yeah, we got banker as a separate term, but banking and bank are converted to bank only. So you know that banker, since banker is a different term and bank is a different term, then this stemmer function is smart enough or good enough to differentiate. You can actually run this. So if I run this, if I can run it for, let's say, set one is like Python. So you can see that if I pass this set one, then what kind of output I'm going to get. So you can see uh, here this set. Sorry, this is like set two only. So let us call this is a set one or set three. We got set three already, set one already. So let's set three. So for all of this Python, Python, this is that has converted to Python, the basic form. So even if like the words like which is in different form, coming in different document or in the same document but in different form, they are all converted into basic form so that we can count correctly and we can form our. So now we are ready to create our bag of word representation, and that's what it is being done. So this is the code for getting the data, loading the data from the positive review, negative review. Where is the data set? So now let's upload the data set here. So one way of doing this uploading is like you can uh, upload the data set from simply upload option, and it will give us a reminder that uploaded file will get deleted when the runtime is recycled. So when you run it next time, right, this Google collapse, then this you may not find these files, so you need to upload it again, because it's a kind of session management. So in one session they remain active and visible, but then as soon as the session ends, these files deleted from 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 their server. So you need to upload again. So I have uploaded. So if you want to see what is RT polarity negative review, so these are the reviews. You can see like here, it's this is one review. This is so 1, 2, 3. Like it's they are containing reviews, right? So all are like. So you can consider like each line representing one single review, right? So there are, I mean, 5,331 positive reviews, and so this file containing negative reviews, this file containing positive reviews, and these reviews are already. What we are going to do, we are going to read these files. That's the Python commands for reading files and storing them in positive and negative file handler, and then what we are not now showing here is that first 5 reviews here from the negative uh, set of reviews which we have stored here in the negative. So if I run this, you can see that this is the first review, this is the second review. So this while loop, which is going up to 5, I mean, starting from 0 to 5, so 0, 1, 2, 3, 4. So total 5 reviews are being displayed here. You can display more number of reviews. So these are the text data. Now the same idea that we have applied earlier, that we will apply the sentence tokenization, and then we will apply the word tokenization, right? Uh, and uh, and then we will be removing stop word, and removing the punctuation marks, and then stemming. So all these things are like now combined here in this function. Here this is stop word function. This is the process sentence function, which will process the sentences. And the same idea, right? Just I've grouped the code so that to make things simple to understand. So what we're doing here is we have created a positive data array, which is like empty array. We are reading one review at a time and appending that, right, after, I mean, when this all sentence tokenization and sentence are processed, right, we got all the reviews in the backup word form, right? So we got the filtered word, right? So now what we are going to do, we are going to append in each of this array, the positive data array, the process sentence p review. This like process sentence is like this function, which is taking one review at a time, which is like tokenizing that review, removing the punctuation marks, removing the stop word from that. Right. So all this like removing stop word, this function is here. So you can see like all these things are taken care. And so finally, what you will going to get is like the backup word uh, with the label as positive and negative. Right. You can so you can see like after running this code, you're going to get your bag of word for positive review or for negative review that looks like this. Like so, it's like his story term, how many times it has come. So this will show only those terms which has come, right? So this is a particular type of representation where we don't show those zeros here in the vector where the words has not come. It will only show the words which has encountered in the review and their possibly the frequency of occurrence, right? And maybe like their presence and absence. So here, like all these words are present. That is the mark. That is the indication of uh, for all those terms we got one as indicating that these words are present in a particular review. So after this we got our data is ready. Now we'll apply the machine learning classifier. So what we do, first we shuffle the data from both the arrays, like positive arrays and negative data array. So those data set that we have now created for machine learning task, right? That's a random function, the function which shuffle function, which will allow these reviews to shuffle so that um, we can say that, yeah, they are organized in a random way. If there is some systematic insertion of this data in the original data set, so that is randomized, right? So randomization is important if you understand like how we like provide carry out the training and then testing. So test training that set is going to be from the first review or the index as 0 up to the like 3000. So 3000 is not included. The second index is not included. So 2999. So from 0 to 2999, again like 3000 reviews. So 3000 positive reviews here plus 3000 negative reviews. These are forming the training set, and the remaining data is going to form is going to getting included in the test set, which is like from 3000 onward for positive as well as for negative. So 2,331 are going to positive reviews, and 2,331 negative reviews are so basically 4,662 reviews are included in the test set, and in the training set 3,000 and 3,000, which is like 6,000. 6,000 in the training set and 4,662 in the test set. That's what is included. Now, once you are done with the training data and test data, now you apply simply you. So basically, you call this naive-Bayes classifier, which is included in this NL library, NLTK, right? Naive-Bayes classifier, and for training, you are providing it the training data set, so training set, which you have already created here. So this training set is passed to this classifier, and after this got trained, and you can pass the test set for computing the accuracy and the other performance. So you can see that this is what is. And for other metrics also, I mean, there's some code which you can ignore here, which also giving not only accuracy but false positive, false negative, the confusion matrix. This is all created programmatically. So that is the code for creating all those evaluation but this is the accuracy part of it, right? So if you run this, right, you pre-process this, and then you run this, so that will shuffle and then create training data, and then this is the classifier. This is how you're going to build it, and then I mean, in the one single sentences, your training is done. Why? Because this train function does all the training tasks. Training tasks is like calculating all those probability values which we have discussed, right? And now we got the test set. So this, again, the single function, this accuracy function, which takes this classifier, this is the trained classifier, and take the test data and compute this accuracy. So that will provide like for what is the accuracy of this classifier on all the test data. So if you can, yeah. So here the accuracy you can get printed, and for rest of the evaluation criteria, for example, false positive, negative, true positive and true negative, and all those. And I mean, we have created this code, right? So this code is going to get printed, and we have already computed this, like true positive and false positive and true negative and false negative. And that is what we are displaying here. And then we are displaying precision as true positive upon, so those precision values also being calculated and all that. So you can see that uh, this is executed, and we got the accuracy is 75%, 75.77% accuracy. That out of like 4,662 sentences, 75%, 75.77% of those sentences were correctly classified. So positive to positive and negative to negative, how many of them were suggested positive and were actually positive? And similarly, true negative, that means they were actually negative, and then we also predicted as negative. But then, so some of them, like, so for example, false positive. So false positive is like they were negative, but our classifier suggested them positive. So that is falsely positive. That's an error, right? Type 1 error, false positive. And false negative, there's another error, like they were positive, but falsely we suggested them negative. So that's a false negative. So this is the errors of accuracy is nothing but this figure, true negative plus true positive divided by sum of all four. That's the accuracy, and you will get this 75%. But then you can further calculate the precision with this formula: true positive upon true positive plus false positive. Recall as like true positive upon true positive plus false negative. And accuracy is like this formula. So you can actually yourself compute this. You can do further, like by passing your own set of reviews. You can provide your reviews with, and you ask this classifier to classify this particular sentence. But before this sentence to be classified, it has to be processed. We have already written this function process sentence. So process sentence will take this function, will process it, and then this classifier will take the output of process sentence and will classify. For example, it is classifying here as negative, and here it is a plus, one of the best movie I ever seen. Now it is giving as positive, right? A real movie about real people. So you can see like it is correctly classifying in all these three cases, and you can also test on your own reviews. And this is how you can. So I will be sharing this code along with the data set so that you can experiment with and can make some changes if you wish. If you are good at Python, you will be actually able to do a lot with this code. But if you are not, then also like you can make some small changes to see and add some your reviews after the training. You can simply add here, for example. So what you can do, you can add another code cell here and copy this sentence, put it here, and you may write, I don't like that movie, right? It is boring, right? And you would like to see that whether this is, so it's a negative, right? So you see, you can experiment with, and the more you know about this kind of algorithm, you can play around this and you can improve this. See, for example, 75% is not a good accuracy. We can increase this accuracy. So how can you increase the accuracy of this classifier? You can make it better. So that is whole idea behind doing research in the area of machine learning and text classification. There are already like a lot of algorithms that people have come up with a better algorithm. So initially you may be just simply experimenting, but later on you may start putting some very good ideas some novel ideas, research out ideas, and that may provide even better performance, all those kind of things. So I stop here and may take few questions if you wish.
So, dear participants, if you have any other questions, you may ask to the sir. Sir have covered a lot of things. It was a marathon lecture, I must say. So,
I mean, if you see some concrete outcome, right? If you learn something and you've seen the application and you've seen that how it works, it is good to know. I mean, end to end.
yeah.
So normally what my efforts used to be that we can make our participants engaged and they find that they've gone through some complete idea starting from very basic, that how we see the text, how do we process the text, how do we make text ready for machine learning tasks, right? So creating your text data set, right? Extracting features from the text data and creating your data set for applying machine learning. Yeah, so
Thank you. Yes, sir.
So I hope our audience are not sleeping or not run away simply because it was like I may have gone a little further.
Please share. Yeah. One question is there: how to create the bag of words, sir? Dr. Sujata is asking how to create a bag of words. So
How to
you might have missed the our lecture part where sir have discussed how to take the unstructured data, then we create a tabular form like a matrix. Sir has created a vector, a multidimensional vector like a matrix. But each and every words you have to present as a column. Then you have to take all the data set, review 1, review 2, review 3. Whether the data that word appear in particular document, it appears like yes, no, or how number of time that word appear. That have sir nicely explained at that part. If you miss it, I will share the that recording. You please revisit it. Sir have covered all that part.
So bag of what is nothing but let's say there is a piece of text. Let's say even like your article. Let's say you have written a paper, right? A research paper, right, which you intend to submit to journal, and you want to create a bag of word for this paper or for its particular section, like introduction, right? So what should be the bag of word representation of your introduction section? So it will be nothing but all those important words which has come in the introduction section. Now, what we are going to do as a programmer, we are going to write a program which will take this text, figure out the sentences and all those in that introduction. So all sentences has to be extracted, and for each sentence, all words has to be extracted. Then we will remove some of the common words, which is like stop word. That is a straightforward way of doing it. And then we'll remove some punctuations also, all those like full stop, commas, like question marks, and all those kind of, right? And then finally what we will have is nothing but maybe we will convert all words into its basic form, which is like stemming. So we'll perform this text processing task, which is like sentence tokenization, word tokenization, then uh, stemming and all those, and then whatever we will have at the end will be nothing but a bag of word representation of that piece of text. So it can be a chapter, it can be paper, article, news article, right, a review or whatever. Like we can convert that as a bag of word, and that's a representation which is like very like familiar with or useful, which can be interfaced with our machine learning algorithm. For example, naive Bayes. So naive Bayes can be applied then on this bag of word, we can get the classifier trained and it can be used for whatever the classification task that we need to perform. Okay, any other question?
Good evening, sir. My name is Dr. Ramesh Naik. It was a very nice session, sir. I'm from Maharashtra. Sir, it is possible we are implementing this code for Marathi text or Marathi language?
Yes, absolutely. I mean, see, whatever I've shown, it's this was in English text, right? So for
Yeah.
Marathi language, I mean, obviously we need a library. So people from what I know is like at IIT Bombay, they have created a library similar to NLTK, which can actually do the text processing, text tokenization, which is like sentence tokenization or word tokenization for the Marathi world,
Exactly,
right?
Amari.
Pardon? Pardon? Hello? I didn't get you. I mean, what I said is like, yeah, people are working there, right? See, for us, it was possible because we have some wonderful library called NLTK, but then that is for, I mean, English language, right? So what we, if you want to do it for other language, it can be done. The idea remains the same. Only thing is like that kind of help in terms of library support. That is the functions which you can use it directly in your code. That we should be looking for. We should be searching out for that, right? If that kind of library available, you can create this kind of application for Marathi language, or you can create these libraries also. The people are actually engaged in that. So what I understand is like IIT Bombay, there is a strong natural language group and they are working on Marathi language. So you can contact them and they may provide you, if they, maybe their site, if they have shared it, I'm not sure. But for Marathi language, it may be that you may get this kind of help. Yeah, I'm getting like tokenization is clear, but before that, need to write code to create bag of bird. Yeah, tokenization. Actually, tokenization in a sense like process step to create bag of bird. Bag of bird is like a collection of bird. You know, you have a bag and you put in a number of words there, right? Now these words are coming from the text, from the intended text or text document, right? So how you finally will have a bag of word, which is like collection of word, which you can use for further like doing some sophisticated tasks like sentiment analysis, spam filtering, like author identification, or sentiment analysis, right? Movie reviews, recommendations, and all those kind of things. So how would you do that? So we have discussed, in fact, in the lecture that how to convert a piece of text which is like unstructured. I mean, it's use lot of like sentences or and it can be very large also. But what we are doing is like we are taking that text. It can be a text of an article, a book, right? Or multiple books, or, I mean, whatever, like. So that text, we are reading it and then applying this operation to create finally a bag of words. That's what we discussed today.
Okay, sir. Thank you, sir. Thank you very much.
Sir,
Any other question you would like? Yeah. Hello?
yeah, anyone having still some question may write on the chat box or ask. If anyone having a question, please.
So I think we are done. I mean, more or
Yes,
less.
sir.
So thank you
Sir,
very
I
much
must say,
again. Yeah, Vivek, for inviting me. It is nice talking you. And
sir,
many times what may happen that see we run these FDP courses at IIITNR Jabalpur and ICT Academy, which is like very well organized, that where each lecture, each session is like connected with other session, right? So right now it's like for me, I mean, I hope that you won't mind this me saying this, but I don't know what is being covered earlier and what is going to be covered in the later part. So putting the right context, the right context, right content also, it's important to have like those interfaces correctly. So for you, I understand it's a hard task because you need to manage many people and they are from different places and will be probably discussing on different topics. So those glue thing, right, which connect these different lectures to provide you a uniform theme or some kind of problem solving end to end, where there are multiple steps involved and they cannot be covered in one single lecture. Then this used to be a kind of challenges. So I hope that you will be managing those.
Yes,
And
sir. Very nice suggestion. Actually, I must say, this is, I think, my 10th or 11th FDP in the last 2 years I am organizing. And that the suggestion is very good. Actually, from the day one, I try to manage or try to arrange the lecture in a such a way so that the people can understand the content. Like this is the third session of your. Before that, I personally covered all the data pre-processing, how importing the data, what is the regression problem, what is the classification problem, what is the class label, what is the target variable. All those things I have covered so that I can build up the understanding with the participants so they can catch up your talk. So really it is very difficult to manage it sometimes, but anyhow, whenever required, I insert my lecture here and there and try to manage the prerequisite if it is required, sir. So your suggestion is well taken, sir. Really very good suggestion, sir.
Chalo, thank you, Vivek. I hope this was useful for you or your participants. And see you later.
Sir, yeah, really, your lecture was so good. You have covered three different big things in a one lecture, and I can't imagine it is possible in a one lecture also. You have covered the text mining, fundamental of the text mining. Then you have covered totally naive-Bayes, joint probability, posterior probability, conditional probability, explain whole algorithm with detailed discussion that is possible. Then at the end, you have demonstrated all the things through the programming. The way you were teaching, it really seems that you love the teaching. You are effortlessly, you are covering all the content. It's really nice. And I must say it was really fantastic and informative session to all the participants, sir. It's really very good.
I mean, it's your kind words and good words, but then obviously we would like to listen from the participants. I mean, who really understand. I mean, you are the organizer, so I don't believe you. And so,
Participant may
we
say,
talk-
please, participant.
so it's okay. I mean, you take feedback from them anytime and share with me later on. Let's stop this session. We have already overrun on that session.
Yes,
And
sir.
obviously
Yes,
we
sir.
should respect participants' time more important. We are already in this business, so we won't mind spending some few more minutes and some more time, but it is the time of the participant which is more important than our time. So thank you very much to all the
Thank
participants,
you, sir. Thank you.
and see you sometime later. Thank you very much. Okay.
Thank you, sir. Have a good day, sir. Thank you.